like long division and stuff like that, I just get really confused. Is there like an easier way? Because I know that we can like do factoring and stuff like that, but like sometimes I don't get how they cancel out.
Okay, so we can go over this, how you do this. There is another way, if you choose to learn it, called synthetic division. I think we went over it quickly, but I can go over it again if you want.
Okay, cool.
It only works if you're dividing by x plus or minus something.
Okay.
So it's
Not
not
like x squared.
correct. It
Okay.
doesn't work in that case. So you do need both techniques. Well, you need to be able to do long division, but you can get around it, like, for some problems by using synthetic division.
Because
Now,
like the book showed an example where you just plug in 0 for the unacounted, I guess like this has x to the cube. Like, I don't know. I got really confused by it.
okay,
So go over this, and then I'll turn this on next week.
okay. We have a little time now, and I can do
Okay.
stuff after class.
Okay.
You want to come up to the board and we'll try this one?
Yeah. Also, the midterm is next Tuesday, or is it? It's not today,
It's
right?
the 9th.
The 9th. Oh, okay, cool. Never mind.
So it's not next week.
The
It's
week
the
after.
following week. This is the week where,
Like review.
no, where this is the cutoff. That is, after this week, anything won't be on the midterm.
Okay.
Not final, but, okay.
Okay.
So let's see, 29. So it's x cubed plus 6x squared plus 0x, we use that placeholder, minus 125 divided by x plus 5.
Oh, no, this one, this one's 0 too. This one's not even in the book. These parts aren't even in the book. It's just, I think it's just x cubed.
Oh, yeah,
Yeah.
sure. Okay, I'm sorry. So we start here, we look at, if we were doing like 105 into like 5, 7, 6, 3, we go like 1 into 5 is 5, okay? So we go x into x cubed, x squared.
Okay.
It actually works better, because here this might not work. This is like a 9, it won't work. But here it always works. So then we multiply x squared into x cubed plus x squared plus 5x squared. Just like with regular division, we subtract. So 0, this is going to go away always. 0 minus 5 is minus 5x squared. And, we'll bring this down.
Wait, why is it minus 5? Because, this whole
Because-
equation is.
Because 0 minus 5 is minus 5.
Okay.
X cubed minus x cubed is 0. So you can write that.
Okay.
I mean, you could, 0x cubed, but it's gone. You no longer care. All right. So this is minus 5x squared. This is 0. So x into minus 5x squared is minus 5x.
Okay.
Minus 5x squared over x. We'll get rid of 1x. Minus 5.
Okay, I get that.
Okay. So now we multiply minus 5x times x minus 5x squared. So that'll go away. Minus 5x times 5 is minus 25x. So we have to be careful here with our minuses. Minus 5 minus 5 is 0.
No, not negative 10x.
Minus 5 minus 5
Oh, so
is
plus.
plus 5, not 5, and it goes away. You don't actually have to think about this first part, because we set it up when we did the, x into minus 5, we set it up so this is 0 minus 25. 25 is minus a minus. You gotta be careful with that. And here we have minus 125. And the last thing we do, we see, just 25x into 25x is 25.
Okay, but what about the 125?
Wait, 25 times x, 25x, 25 times 5 plus 125, and 125 minus 125 minus 125 is minus 250. So we have a remainder. Now, if we just made this a plus, is it supposed to be a plus? Okay, if it was a plus, then this would be 0, and it would be nice.
Okay, so then would you just flip that?
Or you could say minus 250 over x plus 5. It's the same, you know, when we do here with the remainder. You either say this is the remainder, or you say plus this fraction.
Okay. Thank you.
Ah. If you need more help with that, I mean, if you can come to my office hours, fine. If you want to do it after class, we'll do that too.
Okay, thank you.
So, something happened with the homework, and thank you. You don't just get this shirt, but you don't actually have to do anything either. Just supposed to run, but you don't have to. You can just pay the money. I ran. Okay. So my grader says that somehow I gave you the same assignment more than once. So she didn't correct these. So that's why they're coming back without any marks. If that doesn't sound right to you, you can, what did she say? Already have grades in the spreadsheet because they were a part of the ratios homework. We didn't see a point in regrading. Okay. So that would mean you just get more practice. Okay. I was just explaining to Tina why these don't have a grade. Apparently my grader thinks I reassigned something, which is possible. It's possible that's what happened and nobody mentioned it. So, and everything over here is just people sent me new homework while I wasn't watching. You just gave me this, right? Yeah. Okay. All right. Okay. And all right. guess I have to repeat all this stuff 2 times. On the 9th, which is a week from Tuesday, they'll have our midterm. The material today could be on the midterm, but nothing after this. So next week, pay attention, but you know, it'll be on the final, but it won't be on the midterm. There's a sheet on Canvas for the second midterm, and the first thing it mentions is the other sheet for the first midterm is still there. You should know everything on both those sheets, although we won't be emphasizing the earlier material. And you are allowed to have a calculator during the exam if you prefer. I'm going to write the exam, so maybe it'll be helpful for checking, but you shouldn't actually need a calculator to do any of the problems. Again, there's nothing wrong if you find it helpful, you can use it. And what was the last thing I was going to say? Oh, you are entitled to one sheet, 8.5 by 11. I had a student once who I said one sheet, you know, and he came out with a big accordion. One sheet, 2-sided. You can write as small as you want. The more, you know, put useful information. Don't put too much information, because if you put too much information, you know, when you want to find it, probably won't be able to find it. And I think everything you might want to put on there, you can fit on 2 sheets, I think. You know, I mean, you might want to bring the book, but that would be crazy. Leafing through the book during the exam. Okay. Yes?
I think that was sheets first.
Yes?
Can it be graph paper?
You can use graph paper. If I ask you to graph something, I will either have a piece of graph paper, or I will, on the sheet, I will put a graph with lines. But you're welcome if you'd like that. You can have your own scratch paper too. Usually I only do the test one-sided, so you can use the back, but use your own scratch paper for. Yes.
I was wondering, could you do one of the homework problems?
Absolutely.
Okay.
You just have to tell me what it is.
Okay, it's 3x over x minus 8.
I'm sorry. You hear all that noise over here? You have to speak up, or I'm not going to hear you.
Okay, so it's 3x
3x.
over x minus 8
Mm-hmm.
minus, and then 6 over 8 minus x. And then it's adding and subtracting rational expressions combined and simplified.
Okay.
Okay.
There are 2 ways you could do this. I'll just call them the hard way and the easy way. The hard way is, you know that A over B minus C over D is AD minus CB over BD. That is, you can multiply 8 minus x times 3x minus 6 times 8 minus x minus 8 all over x minus 8 times 8 minus x. I'm going to do section 9-1, which is radicals and rational exponents. And before we get to them, I want you, if it's unclear what I mean by these things, a radical is an expression that looks like this. It could have a number here, and it could have an expression here. If it doesn't have a number here, it's a 2, meaning square root. If it has another number like 3, it could be the cube root. And by a rational exponent, what I mean is I have some number, a, and its exponent is a fraction, like 3/4 or half or something. So that's what we're going to talk about today. First thing I'm going to start with just a little bit of geometry. I'm going to draw a perfect square. Well, it's not that perfect. But we make believe this is a perfect square, each with side 1. And we remember there's this geometry theorem we learned called the Pythagorean theorem. And it tells us that in a triangle, a right triangle, so that's what we have in the square, a squared plus b squared equals c squared. Well, my a here and my b are 1. So I have c squared equals 2. If I want to know what c is, it's the square root. Use the radical sign, and that's what we get. Now, we want to be kind of cagey here. Into a cube. Now I connect the opposite vertices here. I've got a triangle on the surface, but now I've got a line going through the cube. And I know this side is the square root of 2. And this side here, the third side of the triangle, is 1. So when I try and find the length of this, I don't know if you can visualize this cube here, it's the line running from one end to the other. I can use this same equation, but now I have 1 squared plus the square root of 2 squared equals c squared. Well, the square root of 2 squared, a number whose you multiply itself by to get 2. When you multiply it by itself, you get 2. 1 squared is 1. So c squared is 3. We get 3 equals c squared. So here, c is the square root of 3. If you can think in multi-dimensions, you could keep adding dimensions here. 4th dimension, 5th dimension, and we would get, with n dimensions, we would get the square root of n for this cube, this multi-dimensional cube. Okay, now, it's good to know square root of 2. Decided I'm going to bring my calculator to class because it makes so many things so much easier. Okay. Square root 2. Square root of 2 is approximately equal 1.414213562, and then some other numbers that the calculator isn't going to show me. So this is one of these special numbers we call irrational. Not only does this stream of numbers go on forever, but it has no pattern. I mean, we've seen numbers like a third that go on forever, but they have a pattern. This irrational numbers will not have a pattern. It's the case whenever if you take the square root of a number, such as 3 or 5 or any number that isn't a perfect square. Perfect square would be like 4, which would be 2, or 16, which is 4, or 125, no, not 125, 25 would be 5. Any number that you put under the radical that isn't a perfect square is going to be irrational. It's going to go on forever. It's not going to have a pattern. So, we just have to live with that limitation when we're dealing with those numbers. What I just said also works for radicals of with a larger number. So while 27 is a perfect cube, right? The cube root of 5 will be, again, some irrational number. I'm just going to just turn these back. Yeah. All right, so what more do I want to say about, a few more things to be said about radicals. If I have an equation, x squared equals a, then the solution is x equals square root of a. Well, if a is greater than or equal to 0, there are actually two solutions. There's square root of a and negative square root of a. By this we mean the positive square root or the principal root. And if we want the negative root, we really should put a minus here. So if I say x squared equals 4, I say what's the solution? Well, it's 2 and negative 2. Right? But if I said x squared equals 5, I have to write square root of 5 and negative square root of 5. And again, by this symbol here, we mean this principal root, the positive root. Now, of course, if a is less than 0, we're finding the square root of a negative number. And when we're talking about the real numbers, that doesn't exist. Right? We talked about, when we talked about functions, we talked about the square root of x. Its domain is just x greater than or equal to 0. Numbers less than 0 are not in the domain. Okay. Now, if we look at the cube root, however, we look at this equation, x cubed equals minus 8. We get something different. X can be equal to minus 2. Right? Minus 2 times minus 2 times minus 2 is minus 8. That is to say, the range of the cube root of x is all real numbers. We're not limited to just positive numbers. Now, if you think about it here, this is a 2, this is a 3, there's a pattern here. If I ask what the range of the fifth root x is, can anybody guess what the domain is going to be? Maybe I should have written it over here. Well, okay, I'll give you an example. Fifth root of minus 1 is, well, it's minus 1, right? I mean, minus 1 times minus 1 times minus 1 times minus 1 times minus 1. Well, all the pairs of minus 1 are just 1. We end up with 1 minus 1. So minuses work. It's supposed to be 5. Minuses work if this number is an odd number. If it's an even number, 4th root of x or the 6th root of x, then our domain is just all positive numbers. Okay. I think most of what I just said, I mean, maybe a little new, but it kind of feels common sense. It's not real complicated. Where we're going to go now is a little trickier. So we want to get into this a little more slowly. So I'm going to look at this expression, the nth root of some number raised to the nth power, where, you know, n is 1, 2, 3, 4, integer. So if you look at a few examples of this, it seems kind of obvious. If I said square root of 5 squared, that would be square root of 5 times square root of 5, but that's obviously just 5. So it looks like this is usually just a. Usually. I said the cube root of minus 8 cubed. Well, we decided the cube root of minus 8 is minus 2 times minus 2 times minus 2. Again, you know, these every 2 pluses cancel. So we get 2 times 2 times 2 is 8, but we get a minus. So it works most of the time. Now, we have to be a little careful here. Because if I wrote, what's the square root of minus 2, now pick a different number, minus 5 squared, you might think that that's minus 5. But for our purposes, the square root of minus 5 doesn't exist. And you can't multiply something that doesn't exist by itself and get something. So this is it does not exist. So that's the case you have to be careful of. If the exponent here and the radical number are even, the number has to be positive. If it's negative, if it's odd, then this is always true. So I guess I'll write it this way. Equals A if n is odd, equals A if n is even, and A is greater than or equal to 0, and does not exist if n is even and A is less than 0. Okay, so if I have the root of some number and I raise it to that number, most of the time it's just that number. Now, having looked at this, now I want to reverse it. what's the nth root of a to the n? This is a little different. If n is even, well, if I have a negative number here, it's going to become a positive number. And when I find the nth root, I'm going to get the positive version of that number. So the way we would write that is, if n is even, nth root of a to the n is the absolute value of a. That is, n is even if this is a negative number, I turn it into a positive number. Let's take an example. Let's say the fourth root of negative 16, how do I do this? Say, yeah, negative 16 to the fourth. Okay? So that's the fourth root of negative 16 times negative 16 times negative 16 times negative 16. But these negatives all cancel. So this becomes 16, or positive 16, the absolute value. On the other hand, if n is odd, we don't have this issue. I take cube root of, let's say, negative 5 cubed. So this is, okay, the cube root of minus 5 times minus 5 times minus 5. Well, pairs of these cancel, but I end up here. This is the cube root of, this is actually 125, negative 125. But that's okay, we can find the cube root of a negative number. It's just negative 5. So, if n is odd, the nth root of a to the n is just a. So, here we have it's not quite symmetry, but if it's even, we get the absolute value. If it's odd, we just get the value back. Over here, if n is even, you have to just be careful that you're dealing with a positive number or it doesn't exist. All right. Okay, so that's, mostly we're dealing with radicals here. I guess we're dealing with radicals. Are there any, this is just important mechanics for handling algebraic expressions. Are there any questions about this? There'll be some homework so you can practice and make sure you can have this down. I'm actually having trouble breathing. I'm going to stop for a second. I'm fully vaccinated, so I don't think there's any issue here. If anybody else has or have any trouble with the mask on.
I have a question.
Sure.
So, do not exist one, the root of negative 5? The reason why it doesn't exist because it's an even. Is that right?
Well, whenever it's even, it won't exist because there's no way to multiply some number by itself to get a negative. If a number is negative,
Oh,
and you
I
multiply
see.
it by a negative, you get a
Yeah, so
positive.
if it was a 3, if
3 is fine.
Yeah, if it was a cube, then it would be fine.
Even a greater than 0, yeah. Oh, and if it's a cube, you don't have this problem.
Like, it's 120. So 125, when it's answer 125, it would be, wait, it was.
Well, if it was the cube root, I'm sorry.
So, okay,
You're
so,
gonna say.
yeah, so, okay, so that one's negative, that the root is negative 25, right? If it was gonna be something, it would be this one, or that one, right? Is it,
Okay, maybe this will help. Cube root of 125 is 5. Cube root of negative 125 is negative 5.
okay, So-
Square root of 25 is 5.
right?
Square root of negative 25 does not exist. So when you've got even radical numbers here, you have to watch out that your number is positive. If you have odd numbers, well, you can always find the root, or there will be a root. But if this was negative, the root will be negative. This number is positive, the root will be positive.
It's an even, okay,
And it's also good to know that, keep in mind that 5 is also equal to the square root of 25, of minus 25 times the square root of minus 25. I'm sorry. That's what I meant. Minus the square root of 5 times minus the square root of 5 is also equal to 5. So there's always two numbers that satisfy this equation if a is greater than 0. So if a is 25, then 5 minus 5. When we write this, though, this way, we mean the positive number 5. Can I just mess this up again? No. If somebody's confused, let me know. I'll fix it. But okay. Any questions about this? The next part, once you get over the idea that it shouldn't be so simple, it's very satisfying. So, it's easy for me to say, well, what does it mean to be like cube root of, it doesn't matter, 17. It means there's some number, I'll call it x, where x times x times x equals 17. Okay, I can use my calculator, I can find out what that number is. It's irrational, so I can't write all the digits. What isn't particularly clear is, well, what does it mean for, actually, I'll put that up. Sorry. I think what I want to say is, it's easy to know what this means. It just means 17 times 17. what isn't easy to understand is, I'll just pick an easier number. What is 2/3 of 8? How do I multiply 8 by itself 2/3 times? I can do it one time. Take away 1/3, well, I don't know, what's 1/3? So it's 8 times itself 1/3. So we need a way to kind of understand what this means. So we're going to start with the simple example. Let's look at the square root of 5. I want to express the square root of 5 as 5 to some exponent. Not quite sure how to do that yet, but I'm just going to go along with that. So I know square root of 5 times square root of 5 is 5. So let me kind of write that out this way. 5 to the a times 5 to the a equals 5 to the, well, the exponent here is 1, right? So now I'm going to recall my laws of exponents. Up till now, as far as I know, they worked on numbers, integers or 0. But my law of exponents tells me that a plus a should equal 1. Recall that? In other words, 5 to the 3 times 5 to the 4 equals 5 to the 7. I just add the exponents. So that's what I'm doing here. I'm just adding a and a equal 1. But if 2a equals 1, then a equals a half. So what I'm saying is that the square root of 5 is the same as 5 raised to the 1/2 power. That's really it's kind of enlightening. Let's try something else. What about the cubed root of 7? Well, that's 7 to some value b. I know that the cubed root of 7 times the cubed root of 7 and the cubed root of 7 is equal to 7 to the 1, right? That's what it means to be the cubed root. You multiply it by itself 3 times and you get the number. So 7 to the b times 7 to the b times 7 to the b, 7 to the 1, or 3 times b equals 1, or b equals 1/3. So that tells me that the cubed root of 7 is the same as 7 to the 1/3. Now, don't be embarrassed. Is anybody, you can just kind of wink at me, oops, this is the first time you've seen this? Anybody? Okay. All right. You'll notice that on your calculator, if you have a fancy one, there's a button here that means exponent. There's also a function square root. Actually, I've seen calculators where they have the nth root. You have to put in 2 numbers. There's no square root on this calculator. That's because they expect that if you wanted like the 7th root of something, like 5 to the 1/7 root, that you'd write this 5 and then you'd put this little character, you'd say 1/7, and it'll calculate it for you. Okay? So let's just write that as a kind of a law of exponents that are fractional. Say a to the 1 over n. That the nth root of a is the same as a to the 1 over n. Well, that's great because not only now we have a little more knowledge, but we don't have to relearn our laws of exponents. Let's say I had something like this. I said, what's 5 to the 1/3 times 5 to the 1/5? I could write that as cube root of 5 times the 5th root of 5, and I'd be in trouble. I wouldn't know what to do with that. But in this form, I can just use my law of exponents. This is 5 to the 1/3, this 1/5. Well, what's 1/3 plus 1/5? Well, I need a common denominator. That's going to be 5 plus 3 equals 8/15. So this is equal to 5 to the 8/15. Now, that might be a little disconcerting. We've only seen a fraction from 1 over n. But then we remember one of our other laws of exponents. If I have x to the a, no, I don't want to write that. I'm going to write it this way. A to the x raised to the y, that's just a to the x times y. We went through why this is true with just regular numbers. It's also true for fractional exponents. So if I have 5 to the 8/15, I can write that either as 5 to the 8 to the 1 over 15, or 5 to the 1 over 15 to the 8th. Now, these are not very nice numbers. We find some nice numbers so we can actually do something with this. I mean, we could use a calculator on this, no doubt, but if I had 8 to the 5/3, okay, I can work with this. This is the cube root of 8. Well, let me go through the steps. It's 8 to the 1/3 to the 5th. Because 1/3 times 5 is 5/3. That's the cube root of 8 to the 5th. And the cube root of 8 I know is 2. So this is 2 to the 5th. And if I do a little work, I'll find out 2, 4, 8, 16. This is 32. So 8 to the 5/3 is 32. This is how we work with fractional exponents. Let's see if I can find another good example. Well, this is a different kind of example, but if I wanted to simplify x times the 4th root of x, I can convert these both so that they have an exponent. This is x to the 1 times x to the 1/4, which again, according to my rules of exponents, is x to the 1 plus 1/4, which of course is x to the 5/4. And if I wanted to write this you know, a little differently. I have a lot of choices. I could call it the fourth root of x to the fifth, or I could call it x to the fifth root 4. But we're not going to run into it today. You do have to be a little careful here. Remember, again, if x is a positive number, no problem. If x is a negative number, well, we can't take the fourth root. A negative number. We're kind of out cold. And we're not going to fix it this way either. When we take x, which is negative, and multiply it by itself 5 times, we're still going to have a minus 1. Okay. All right. Here are a few examples. I'd like you to try these. I'll go over them. Everyone, if you have some paper, take 81 to the minus, we're throwing in a minus. I hope that doesn't confuse it too much. See what you could do to simplify 81 to the minus 3/4. Just in case anybody's stuck, anyone want to tell me what I do with that minus sign? How I can kind of eliminate it from the complication here?
Can you put it in a denominator? Can you flip it like and then just put 4 plus 3, 1?
That's exactly right, Tina. Just like any other negative exponent, I can just say 1 over and the minus goes away. Thank you. So now we just have to look. Okay, anyone want to give me have any ideas how to simplify this? Just give me one step. Yes?
Put 81 in a radical of 4.
I heard radical 4. Oh, 81, radical 4. Where does the 3 go? Like here, maybe?
Outside the parentheses, under 1. I think so.
Okay. You can do it both ways, but this is going to be easier. I mean, I can multiply 81 by itself 3 times and try and find the 4th root. That'll work, but that would be more work. Okay, so if you haven't picked up on this already, you want to notice that 81 is 9 times 9, which is 3 times 3 times 3 times 3. We got 4 of them, right? So the fourth root of 3 times 3 times 3 times 3 is just 3. And we need to cube that. So that gives us what? 1 over, like, you guys are dead? 3 times 9 is, I don't know if everyone can do that. Okay, good. So 81 to the minus 3/4 simplified 127. Let's try 8 over 27 2/3. Throw any ideas out here? We got a lot of exponential rules here. It's confusing at times, but this is 8 to the 2/3 over 27 to the 2/3. Right. And 8 to the 2/3, that's the cube root of 8 squared. And 27 is the cube root of 27 squared. From there, it's pretty straightforward. Cube root of 8 is 2, squared is 4. Cube root of 27 is 3, squared is 9. All right, one more, a little more abstract. Cube root of x to the 4th. Simplify that any. Not really. I mean, we can write it a different way. We could write it as x to the 4/3. Or we could write it to the x to the 1 times x to the 1/3. 1 plus 1/3 is 4/3, so it just be x times the cube root of x. It's not really any better, is it? I don't know why this example. Okay, there's one more subject for today, and related to this. I think it's pretty straightforward. Since we know that you can't find the square root of a negative number, if I have a function like this, square root of 2x minus 1, I want to know what the domain is. How do I do that? Well, really what I want to say is 2x minus 1 is greater than or equal to 0. That's my domain. And I can simplify that a little, right? That's 2x is greater than or equal to 1, or x greater than or equal to 2.5. you go, let me ask you a quick question. What is the domain of this function? Yes?
Would it be, x is greater than or equal to 9
Well, you're very close. Let's work it through. 2x plus 9, did I hear that right?
Yeah.
X is greater than or equal to 0. So I subtract 9 from both sides. Okay. It's the I got it moment, right? Everybody see that? We just need to add a minus to the 9 halves. Okay, thank you. Have a good afternoon. If I haven't accidentally posted the homework on Canvas, I will do it tonight. Thank you.